Thank you for joining me. Welcome to TJ's Maths Clinic. In today's presentation, we continue with our solutions to sequence and series. The subtopic before us is geometric progression or exponential sequence. With us here is example 2. In my previous video, I've solved example 1 under geometric progression. Question 2 or example 2 read, the second term of an exponential sequence, that's geometric progression, is 9. Well, the fourth term is 8 to 1. We are asked to find the common ratio, that's number 1, the first term, and the sum of the first 5 times of the sequence. The sequence now is exponential sequence. Let's look at how we can handle this together. First thing to do, let's write down the solution and see how we can solve this. Let's recall first, for us to approach this, we have to recall the nth term of geometric progression. Very important. Okay, so that we can interpret the second term as well as the fourth term. Okay, nth term of geometric progression, nth term of GP is given as the term now will be equals to A, that's the first term, multiplied by the common ratio power n minus 1, where n is the number of terms, A is the first term, R is the common ratio, second term. If we're looking at second term, it means n is equals to 2. So let's substitute n equals to 2 into this nth term. So T2 now will be equals to AR power 2 minus 1. This will be AR 2 minus 1, of course, is 1. And we are told that the second term of exponential sequence is equals to 9. So this will be equals to 9. Let's call this equation 1. Very important. Let's move to fourth term. Fourth term now, it means n is equals to 4. Then we substitute n equals to 4 into this nth term. So T4 now, that's the fourth term now, will be equals to A multiplied by R, which is the common ratio. Power n minus n now is 4 minus 1. This will now be AR. This is now AR, 4 minus 1 is 3. And we are told that the fourth term is equals to 81. Is equals to 81. This is now our equation 2. Under geometric progression, anytime we form two equations, the next step is to divide equation 2 by equation 1. Very important. So at this point, the next step, we will say divide equation 2 by equation 1. Very important. Okay, let's move here. Let's move here so that we can do that. Our equation 2 is AR power 3 equals to 81. Then equation 1 is, we divide this now by AR, then we divide this by 9. That's what it means. Divide equation 2 by equation 1. The aim is to find the first term and the common ratio, respectively. So at this point, we can divide this. A divided by A is 1. R here 1. R here will be left with 2R. That's R squared. Be left with R squared. Okay, this will now be equals to 81 divided by 9 is 9. At this point, we can find the common ratio. So R squared will be equals to 9. To remove this square, we take the square root of both sides. We take the square root of both sides. R now will be equals to 3. But it's supposed to be plus or minus 3. But let's pick 3. Because anytime you take the square root of both the left-hand side and the right-hand side of rational real number, you must put plus or minus. So the question says find the common ratio. Ideal, our common ratio is supposed to be plus or minus 3. Very mathematically, It's supposed to be plus or minus 3. Then the first term. Let's look at how we can find the first term now. To find the first term, we use one of the equation. Let me clean here. Our common ratio now is plus or minus 3. So we are through with the first one. Next, the first term. Let's use equation 1. Our equation 1 is AR equals to 9. So put R equals to 3 into equation 1. Okay? So it will be A multiplied by 3 will be equals to 9 now. So 3A will be equals to 9. Divide both sides by 3. 9 divided by 3. A now will be equals to 3. If we use positive 3, we'll get A as minus 3. So it means when the common ratio is negative 3, we'll get the first term as minus 3 as well. If we choose to use either positive, but I'll choose to use positive in this case. Very important. Okay? The next thing to do now, the last part of the question, we are asked to find the sum of the first 5 times of the sequence. Very important. This word first 5 times means n is equals to 5. First 5 times means n is equals to 5. We are asked to find the sum. Okay? So since the common ratio now, there are 2 ways to this. If we use our common ratio as r equals to 3, we will use the sum of GP when r is greater than 1. So sum of GP when r is greater than 1. But if we choose negative common ratio now, which is minus 3, r will be less than 1, and we use different formula. Okay, let's move here. So the sum formula now will be sum when r is greater than 1 will be A into r power n minus 1 divided by r minus 1. This is when r is greater than 1. We are using r as 3 now. Very important, given that n is 5 and our first term is 3. So let's substitute. Sum of the first 5 times now, n is 5, will be 3 into r is 3 power 5, then minus 1 divided by 3. Our common ratio is 3 now minus 1. So let's simplify this. Let's work inside the bracket first. Very important. To simplify this, it will be 3 into 5 power 3. Let's do 5 power 3. That's 243 minus 1 divided by 3 minus 1 is 2. This will now be equals to 343 minus 1. That will be 242 times 3 times 3. That will be 726 divided by 2. What will be the sum now? Sum of the first 5 terms now will be 726 divided by 2. That will be 363. So this will be the sum of the first 5 terms. Let me take it up here so that we can see it clearly. As I said, from here, we can say 243 minus 1 multiplied by 3. We'll get sum now will be equals to 726, because 243 minus 1, it will be 242 times 3. That will be 726 divided by 2. The sum now of the first 5 terms will be 726 divided by 2. That will be 363. So this will be the sum. I decided to take it up here so that we can see it clearly. So this is the solution to this question. Our first term is 3. The common ratio is positive or negative 3, but I decided to use the positive 3. Common ratio is plus 3. First term is positive 3. The sum of the first 5 terms is nothing but 363. So this is the solution to this question. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths Clinic for more interesting videos. In my next video, God's willing, we'll look at more examples from this geometric progression. Thank you for watching. You can follow me on TikTok, Instagram, and Facebook. See you in my next video.